this video, we will be looking at regression and R-squared. When we talked about correlation, we talked about how we can use it to measure the direction and strength of a linear relationship shared between two quantitative variables. But when we talk about regression, we talk about making an actual line on the graph. This is a line that represents the pattern of data, and this line is known as the regression line. A regression line predicts the change in y when x increases by 1 unit. The change in y describes either an increase or a decrease. So for example, if we have study time on the x-axis and GPA on the y-axis, we could expect a positive relationship between these two variables because generally speaking, the more you study, the better your GPA will be. Now if I replace study time with time spent on Facebook, we could expect a negative relationship. The regression line can be described using this formula, where y hat is the predicted value of y, b naught is the y-intercept, b1 is the slope, and x would be any value of x. If we go back to the first example, y hat would be GPA because GPA is listed on the y-axis. And since study time is listed on the x-axis, x is equal to any value of study time. b naught is always equal to the y-intercept, and b1 is always equal to the slope. Notice how the slope is pointing upwards. Because of this, we have a plus sign written on the formula. In contrast, in this example, notice how x is now equal to the time on Facebook. And like before, b naught is always equal to the y-intercept, and b1 is always equal to the slope of the line. This time, the slope is pointing downwards, which is why we have a minus sign written on the formula. When we mathematically examine this formula, we see that b naught is equal to y bar minus b1 times x bar, and b1 is equal to r times the standard deviation of y divided by the standard deviation of x. So let's see how we can use these formulas in practice. Suppose a researcher wants to predict a student's GPA from the amount of time they study each week. First, the researcher needs to gather some data. We can then begin by making a graph. Since the researcher is trying to predict a student's GPA, we will have GPA on the y-axis. So by default, GPA will correspond to the y values, and study time will correspond to the x values. Then, we could choose to make a scatter plot with this data. Recall that when we are dealing with regression, we don't really care about each individual point. We are only interested in the line that represents the pattern of data. In order for us to use the regression formula, we need to calculate the mean and standard deviations for each variable, which you should already know how to do. We also need to calculate the correlation, which you should also know how to do. We needed to calculate for these values because b naught is equal to y bar minus b1 times x bar, and b1 is equal to r times sy divided by sx. When we solve for the value of b1, we get 0.311. And when we solve for the value of b naught, we get a value of 1.45. Therefore, the equation for the regression line will be y hat equals 1.45 plus 0.311 times x. This means that the value of the y-intercept corresponds to 1.45, and the value of the slope corresponds to 0.311. When you calculate a line using this formula, it can also be called the line of least squares regression. The slope of a regression line predicts the change in y when x increases by 1 unit. So in our example, the slope is equal to 0.311. Therefore, we say that as study time increases by 1 hour, we predict a student's GPA to increase by 0.311. We can actually use this equation to predict a value of y using any value of x. For example, based on this data, if we have a student who studies for 6.5 hours a week, we can predict this student's GPA. All we do is plug the value 6.5 into the formula, and we get a y hat of 3.47. This means that, for someone who studies for 6.5 hours a week, we predict their GPA to be equal to 3.47. The last thing I want to talk about is r squared. R squared is literally equal to r squared, or r times r. Do not get confused between r and r squared. R has values between -1 and +1, whereas r squared only has values between 0 and 1. Correlation measures the linear relationship between two quantitative variables with respect to direction and strength. On the other hand, R-squared is a measure of how close each data point fits to the regression line. So in fact, R-squared tells us how well the regression line predicts actual values. Let me show you what I mean by this. Consider this scatter plot. Each blue dot represents an actual value, and from this data we can make a regression line. Now any point that falls on the regression line corresponds to a predicted value. So in general, an R-squared that is close to 1 tells us that the predicted values and the actual values are close together. In contrast, a low value of R-squared tells us that the regression line doesn't fit the data that well, and we can clearly see a large amount of distance between the actual values and the predicted values. And if R-squared is exactly equal to 1, this means that we can predict the value of y for any given value of x. Note that R-squared also tells us the percentage of variation in y that is accounted for by its regression on x. So in our previous example, we had calculated r to be 0.94. The R-squared value would be equal to r times r, or 0.88. So this tells us that 88% of the variation in GPA is accounted for by its regression on study time.